Hello and welcome back. My name is Corey and you're my rubber ducks for the evening. And this is the series where we are creating a programming language from scratch using nothing but our C++ coding abilities and a few tools like Flex, Bison, ICU, Google Test, Vim, Make, stuff like that. And we have a pretty good product at the moment. We've got a language that can do a lot of stuff, and we are in the middle of refactoring the way that strings work. That's the goal. And as part of that, it's got multiple parts of getting these string refactorings to work, or multiple steps, I should say. And our goal today is that we want to focus on our UnicodeString class. Excuse me. And what is that going to be? Well, our Unicode strings are kind of like our basic storage unit, and then our computed expression string now will store chunks of those units. And, well, the goal of what we're trying to do here is that we want to right now, like I said, the computed expression string stores multiple chunks, and we want to attach a piece of information to basically say, well, what is the nature of the string? Is it, and we're going to use the word, I think, trusted or untrusted. And if it's a trusted string, then that means, you know what? I trust that whoever told me what it was knew what they were doing, and it is in the format that it should be in. But if it's untrusted, that would be like a user-provided string. Then that means when we finally convert it or we finally print it out, we should escape it with whatever escape method. That's what we're going to look at. So let's go to our code here. I've always said nothing up my sleeves, right? I haven't prepared anything. Nothing up my sleeves figuratively either. But if we say, I evidently don't have the window highlighted. On the right-hand side, I'm just going to go ahead and say make clean, and then make test-watch. And on the left-hand side, we'll show git log. The very last commit that was made was episode 62, getting into that. And then, that was the end of the previous episode. And then if we say git show, we'll see, not git show, that's the last commit, which was updating the docs. Git status, it starts with an S. I haven't changed any files. So we are on a clean working directory. And I think, like I said, we're about to start doing the Unicode string. So we're going to need to edit a test file, but which one? Let's edit test Unicode string, and we'll start there. And also our include for Unicode string and our source for Unicode string. And on the right-hand side, you can see all of our tests are passing. That's always a good place to start. So what should this look like? We've got an unescape, where that's an unescape function. We've got an HTML escape. And Unicode string. So testing the substring functionality. What else? Oh, that's it. Okay, so let's just so I don't have to type everything again. And this will be constructed string. Okay, and so what we're going to have is we're going to have UnicodeString S, and by default it is going to be how about just an ampersand? Okay, and now I want to say expect EQ S dot, and I'm going to say, how do we want this? Rendered. We've got, if I go up, we've got HTML escape ASCII, HTML escape. You know what? Let's just do HTML escape. Forget render. Well, I'm thinking through what's this API going to look like. No, I'm just going to say render. And for right now. And right now, this should come out with just an ampersand. But if I have the exact same thing and say, can I say, I kind of want that. Yeah, I think that's what I want. So untrusted, and this will be a default trusted string. Okay, so that's what we're going to build. It's not going to compile yet because we need to, quite frankly, come up with these things. And this is not a substring. This is our types. All right, and we don't have a render. We're going to get that. And what do we need to do there? So we've got our string, our HTML escape ASCII. We've got our public. And you know what? I want to look at our WSL view docs HTML index. There we go. This is our documentation. And go ahead and get the test working again. All right. Enumerations. So in the AST node binary, yeah, we declared operation. And what did that look like? I just don't remember. So let's edit the include for AST node binary. Yeah, enum, whatever. Okay. And what do we want to call this? Type? Sure. And trusted? Oddly enough, I think we need a few more spaces. And this is going to be string is from a trusted source. Untrusted. String is not from a trusted source. And this is going to be being created, and we're going to, in our constructor, have the type by default we'll say trusted. That should make everything work as it is currently working. And now we've got no declaration because we need to put this in. But before we do that, being stored, and that's going to be a Unicode string type. And now for our constructor, okay, that's the first thing. Oh, we still don't have the render. Let's do that. Now, what is render going to be? It is a function that will in render a string Let's start off with dangerous characters, HTML encoded, if untrusted, if the string is UnicodeString type untrusted. And that was way too many things there. So we need the return to be the rendered string in according to its type. Yes. And what will this look like? A standard string render const Delete that extra space that shouldn't have been there. And now we need to create this. String render const For the moment, it's just going to return itself. Oh, yeah, non-member functions, because I didn't tell it was part of UnicodeString. So, only one failed. Now what we want to do say is if this arrow type is equal to trusted, and I don't remember what the unescape. So we've got HTML escape and HTML escape ASCII. We'll start off with HTML escape, but I don't remember if that only does the dangerous ones. See if it will deal with that. All of our tests are passing. Okay. So this HTML escape, only critical characters will be escaped. So a trusted string and an untrusted string, and if I do this, if it is yep, that is exactly what I expected it to be. Ampersand LT semicolon H1 ampersand GT semicolon. So trusted string should pass through. Untrusted should do this. Oh, I'm saying they're both untrusted. This should be trusted. I could have left it empty, but that test has already been made. Everything's passing. So that's good. Okay. We're going to stop here for just a moment and make a commit. And we've added an enum type We've changed our constructor. We've added a render. UnicodeString render. And our tests. Okay. Types of Unicode strings. Okay. Get back up to the tests. Now what? Let's add one for the HTML. I mean the full ASCII encoding. And what would that look like? Let's see. Let's just say render ASCII. Sure. And hello, new line, world, exclamation point, H1. Sure. And if it's trusted, no, this isn't going to quite work. But you know what? We're going to do this. I'm going to complete this idea. Untrusted string. And we don't have a render ASCII function, but we're about to create that. So we've got unescape, HTML escape, ASCII. But all others will be replaced by their HTML escape sequence if it exists, or the proper hexadecimal escape code. Yeah. But, and I think this is the crux, we need to have a version of this HTML escape ASCII that does not escape the quote dangerous ones. Okay, well, we'll get to that in just a moment. So this video just got a lot more complicated. I already know it. So we've got our render. with all characters, not just HTML encoded, all characters converted to an ASCII representation. If the string is, that's what we need to say. So if the string is trusted, then the dangerous characters will not be, is that how I want to say this? How about this? Start with the dangerous characters will not be HTML encoded if the string is trusted. And what did I call this? Render ASCII, I think. And for that, we need this, we need our render ASCII. Nope. HTML escape full. What did I call it? HTML escape and HTML escape ASCII. This is not quite right. Right now they're going to both be ASCII, but oh boy. No, I know what it's doing. If you can tell. Well, I didn't have either one of them, so the test fails on both of them. And right now they're doing the same thing, which they shouldn't do, but we'll change that. But ampersand less than, h1, ampersand greater than, hello, ampersand new line, semicolon, world. And the question is, see, ampersand exclamation point, less than, and then the slash, h1 greater than, yeah. Well, that's the backslash. I'm not saying that that's wrong. It's just the question is do we want everything going through an HTML element? Let's consider this. So right now, HTML escape ASCII. we have our HTML escape ASCII thing, and yeah. So what does this look like? Let's open we just used Flex for this. HTML escape ASCII. You see, we're doing all of this. And if I just ZC there, collapse 1400 lines. Decode 1, decode 2, code 3. Now, so this is a 1 byte thing. You know what? I thought we were doing something slightly different. So decode 1 may be a special case. Decode 1, here it is. No, we just say if it's at. Okay, not control, colon E, edit, flex, HTML escape. Let's see what this one does. Five characters we want to escape, and then we return YY text. So that only escapes these 5. Is there any others that we need to? I don't think the unescape has anything magical in it. I mean, it could be wrong, but I don't think it does. No. Nope, it doesn't. So what's the issue? I don't think that I like it including every single little thing. That, in other words, that may be a little bit much. But for the invisible characters and the control characters, that's my concern. Okay, so what we're going to do is decode 1, and there is a function, C++, it's a char function. What is it? Well, it's one of these, like, so is alpha. That'll get us close to it. It's in the same function, or the same thing. Is graph, I believe that. Graphical representation, blah, blah, blah. I think is print is better. Is the opposite of a control character. Okay. That should let most things through. And we're in CC type, but it might be included automatically. Let's find out. What did I say? So if is print, Now this is not going to be right. In fact, I already know where it's going to be wrong. It's not going to take into account the special characters. But just for the moment, I want to show you where this helps us in this output. So here it's not catching the special variables. This let through everything except the new line, which might be acceptable, except for the special characters that we need to grab. So that should be an exclamation point. All right, so if it is printable and it's not any one of those, return it directly. That's the first thought. Oh. YY text is not declared. Oops. Substitute YY text for S. All right. So at this moment, the new line the exclamation point is now not being changed. And the less than and greater than is not being changed. Wait, no, it is being changed. I was thinking the slash in between them is not being changed, which is kind of what I want. So I think that is appropriate. Now the question is how can we do this I don't want to have to make two of these. I want one to do it where it's no, it's everything's going to be encoded, and another one where it doesn't encode those. In other words, to have a trusted version and an untrusted version. So we're on number 5. Okay. HTML escape ASCII. I think we can pass in a type call it type, and when we create this, pass in type. Can we do that? I mean, I think we should. Let's see. All right, now the only problem is it's thinking we need a forward declaration. Can I do it this way? Don't know. Never tried. Type does not name an enumeration on line 16. Well, okay. Will it allow me to do that? I don't think so. Yeah, it's not. One last, if I just type, I don't think it will. Nope. All right, so what I think I'm going to need to do is for all of these down to HTML escape ASCII, put them after the class. Should allow that much. And now we don't have a match for the type. So let's do that. Include. This is not an AST node. This is it's not a computed expression. HTML escape ASCII. Okay. Now we got all the YY flex elixir and blah blah blah. But we've got this, and we need our Unicode string type with a type. And let's just store that. All right. Private, and this will be the Unicode string type. Are we pound including it? Probably should. Really? Oh, because it should be a lowercase u for Unicode string. Okay. Now, too few arguments in UnicodeString.cpp. For 3, line 146. Okay. Just pass in a type now. Okay, so where is our Unicode string? Equals what should this be? It defaulted to doing everything. Let's see what happens. Well, we still haven't taken into account the trusted versus untrusted. But let's see this now. All right. I must pass that in. Just see if that compiles. UnicodeString has not been declared, blah, blah, blah. Oh, is that because... Just making sure it compiles. Okay, so we're getting this type passed in. And now, that was deleting a little much. Now what we want to say is if type is equal to and trusted. If it's trusted, oh, wait. Yeah. This puts us back to where, well, kind of where we thought we would be. So what are we saying? If it's trusted and it's printable, wait, so if it's trusted, the string is trusted, meaning don't change something. And it's printable. And this would be the opposite. So untrusted, what's my default for this? What did I just create it as? Default is untrusted, which should mean encode everything, right? Trusted, don't encode the special characters. So now that brings us to here. So if I'm decoding something, when do I want to return? When it's all right. I don't like the way I wrote this because it's so what I'm wondering is, okay, so if S0 is, so if it's any of the first letters, return it. So if it's trusted and just saving that. I'm just curious, what's going to happen at this point? How's it going to affect our tests? Okay. Now, I still hate it that we're passing everything through. But maybe we need to. I think I want to do the question is that all I need? Maybe I don't need any of the other stuff. Maybe I'm just making it too difficult on myself. The reason is, on this right-hand side, I'll scroll up after it prints. There we go. This first one is a trusted one. How do we know that? Because it let these through. But it wouldn't actually work because we escaped out the slash. So I'm thinking if it's trusted, we shouldn't escape out the slash. Now the new line still got escaped because we're doing, ASCII encoding this. But, yeah. Whereas, otherwise, everything's getting escaped. Yeah. I think I like that. I like that approach. So we don't need any of these because they're all subsumed into that. And we still have to fix our tests, but they should fail in the way I'm expecting them to fail right now. And the answer is yes, they're failing in the way I expect them to fail. Okay, so let's fix that. So a trusted string that we are rendering ASCII, the new line should be ampersand new line semicolon. That's fine. And then the untrusted string should be a lot of different stuff. Ampersand LT semicolon, ampersand GT semicolon. The new line is still a ampersand capital NEW capital LINE semicolon. The exclamation part is ampersand EXCL semicolon. And now ampersand LT semicolon and ampersand SOL semicolon ampersand GT semicolon. Now if this is right, then that means it's not right. Oh, because I have a percent LT instead of an ampersand. Because evidently I don't know how to type an ampersand. Yeah. Okay, so now we've got trusted and untrusted strings that we can get in ASCII or in full encoding. Yeah. Okay. So arguing with myself mentally, do I want to add any more tests to this? You say, Corey, it seems kind of light, the test that we've written. Well, that's because if we go up, we've already tested these quite a bit in our substrings, in our right up here in escaping. We know that our escaping works. This is just to test whether or not our functionality of giving it a type when we create it is working. Yeah. Okay. I think let's see. UnicodeString, that's fine. That's where we moved it. HTML escape ASCII, we have to pass in the type. Why do we not have to pass in the type to HTML escape? Because we just don't call it if we don't need to. But the point of the HTML escape ASCII is to convert it to all ASCII characters. All right. And what did we call it? Okay, I think I like that. And with that, here's a good place, I think, to stop, because what are we going to be doing next time? Well, next time we want to bring this into our program, our programming language, that is. We want to be able to say, oh, I'm getting a message about OBS. It's like there was a big yellow square, a big red square, and it was that it had disconnected from Twitch, because I stream at the same time as I record this, just to keep myself focused. Anyway, okay, so back to what I said I was doing. For Tang itself, we want to start tapping into this, and as I see it, any double quoted string would be a value that is what's a good way of putting it? Any double quoted string would be a value that is trusted, because it was set out explicitly. So therefore, if a string is passed in, however, from some outside library, of course it's up to that library to say what it is. Is it trusted or untrusted? But for example, if it's a user's name that they typed in, well, okay, it should be considered as an untrusted string. And when we say print, it should then escape it as necessary. And which does it escape it as? Does it escape it as the UTF-8, which is just, what do we call that, render ASCII, or render HTML? Or no, that's just a standard render. Or does it need to be the ASCII only version of the encoding? And that can be actually a mode in the program. So the program, when you create it, that can be an option to say, we'll set it as ASCII only, or set it, well, its default would be UTF-8. But that's fine. Just in the op print, that opcode, when it executes the print statement, it can call the correct function. But the main point is that when you print, right now, how we've modified our program, right now when you print a string, remember a string is made up of chunks, and each chunk is a Unicode string. And now, because of what we just wrote, each one of those Unicode strings knows whether or not it is trusted or untrusted. So we'll loop through and say, print it out as, again, an HTML escaped or not, depending on whether or not render it. And it'll say, well, am I trusted or am I untrusted? And it will take the correct course of action. That is what we've been doing, and it's a lot of groundwork to lay all that out, but we're almost there. So now, left-hand side here, let's make docs-pdf, and while that's going, I'm going to say, what episode are we on? We are on episode 63. There we go. Figured we'd have a few new things. Yep. $63. All right. Get all that pushed up to GitHub. Git tag-a episode 063. Our message is 063. And our lines It's like that took a lot longer than normal. But our lines of code, definitely still over 3,000 lines of comments and 9,300 lines of code. Still thinking we're going to hit the 10,000 lines of code, but maybe not. Maybe we'll be scraping just under it. We'll see. When we get to the where we're writing optimizations, that'll take a little while. So what's the next episode going to be? Like I said, we want to be able to continue with this, supporting our Unicode strings, these different types. However, we don't have a way to create any Unicode strings that well, maybe there is. I was going to say, we don't have any way of creating a Unicode string that I know I just stopped because I'm thinking, oh wow, I know I could do it this way, could do it that way. We could add, just like we have the length on the string, we could add a function that's called safe or no, trusted or untrusted, that would return a version of the string where everything, all the chunks in it are either trusted or untrusted. We could do that. We could do that. But that's harder. Yeah, we'll think about it. But what I was going to say was we don't have a way of creating a string that is trusted versus, well, excuse me, untrusted, because by default everything is trusted, just the way that we've created our strings. So we may look at that next, and just to, again, it's kind of like having to prop up a car by running around to each corner and jacking up that corner. And so that's what we're doing. We started on one, we run to the next corner, now we add that functionality there. And so it's like we're running around, each one kind of requires the previous to be in place, and with the end result being the functionality we're after. We're close, though. We're close. All right. Having said all of that, you've heard me ramble enough for the night, and hopefully you can see the direction we're heading in. And with that, I will say thank you for joining, and hope it's been helpful. Thank you. Have a great day, and bye.